All right, welcome to class Tuesday for physical science. It is 8:27, and we were just talking about some of our favorite foods. I don't think anyone was able to guess, though, based on the descriptions, what they were, but maybe we'll try this again next time or another time. All right, just remember to park it. Yes, participate in all your classes, attend them, read and respond to emails, complete all assignments. Where's my red sparkly pointer? You should be logging into Clever and going from Clever to get to all your other locations. And good morning, Rukaya. And good morning, Jalen and Isabel and Isaac and Anna M. And I said hi to Amanda. Good morning, Maya and Miranda, Quentin, and Leilani. Glad you guys made it in here on time. Appreciate that. That's one of our Class Connect Code of Conducts. Also being respectful and courteous, and you guys do a great job of all of that. Oh, I'm pushing too much. Okay, I got the red X's in here today. So this is our knowledge check about yesterday. So radioactive isotopes have nuclei that do what? And did you guys catch the grammar error? I totally didn't see that. Oh, it's hiding behind the taco. It's not gone. It's just over here. It's hiding. If you can't hear me, click your gear and refresh to here. So gotta refresh if you want to hear. My mic is on. You can tell my mic is on because it's green. If my mic is off, then it's going to be solid white or clear white or gray, whatever color is behind it. So that way you can say, hey, turn on your mic when I don't have it on. All right, I need for everybody to participate. So I'm missing a bunch of answers here from like Hadia. Thanks, Isabel. Jalen, Cameron, Jordan, Juliet. Hello, Juliet. What do you think the answer is to this one? I'm waiting on Kate and Leilani and Kessler. Thank you. Nigel, Quentin, and Seth. Good morning, Seth. What do you think the answer to this one is? All right, so the answer here, oh, you don't know yet? Then you should give me a red X, and that way I know that you are listening and participating, but that you have no idea. You can always give me that red X while you're thinking, and then I know you're here. All right, so radioactive isotopes. That means that their nuclei, by definition, is not stable. And in fact, they are completely unstable all the time. And remember, they have a half-life, which is the time it takes for half of a sample to degrade. And let's see, I'm going to need a little piece of paper for today. I'll use yellow today. So, and maybe I'll save this when we get to it in the PowerPoint. I want to do things ahead of time. So this is just a definition, and it should be smiley face. So radioactive isotopes, by definition, their nuclei are unstable. And they're unstable because they have too many neutrons or not enough neutrons. So there's something unstable about their neutron number. It's not the right number of neutrons to glue the nucleus together. So the nucleus falls apart. Or things change. Sometimes a neutron turns into a proton, vice versa. So if you understand that this is the correct answer, you should be changing your answer to a smiley face. Excellent, excellent. And I'm just going to take a snip here of who is participating and who is not for my records there. Fourth. Today is 8/27. Because I would like you all to be participating in this stuff. That's how you learn best, is through participation. And again, it's fine to get these wrong. No problem with wrong answers, because we'll fix them right up and get them back to being correct. All right, so carbon dating. What two things must be true about a sample in order to date it by radiocarbon dating? By evaluating the decay of carbon-14. So let's take a look, and are there any of these that you could definitely eliminate, like cannot be the right answer? You put that in the chat. And why are you getting rid of smiley? Right, fossils are organic. They're carbon-based. Carbon equals organic. So that's definitely a good thing to know. So it has to be organic. Let me see, I'm gonna cross my fingers and annotate here. Oh, it worked. All right, it usually works the first time. So I'm gonna get rid of this because of the inorganic. It can't, that is not right. And go ahead. Oh, someone had turned on their mic. I thought you might want to talk about what other one you would like to eliminate. So in the chat, or you can pick up the mic, what else would you eliminate? Yeah, we could eliminate died recently, because these are to date fossils, and in order to become a fossil, you must be in the ground. The bones have to be in the ground for very long periods of time, long enough for the bone to turn into stone. So we can get rid of the turtle. Okay, hand, why are we getting rid of that one, Isaac? This is what I looked at. It must be a land animal. Like that, you know, you can have fossils of any animals. Yeah, and that died recently. So that one, the turtle one, was all not good. Okay. Oh, and this one has the same thing. It's got the died recently and just the marine animal. All right, so fossils are very old. So you didn't even need to really know the time frame, but or you didn't, or you either needed to know that time frame or the difference between organic and inorganic to do this one. So the half-life of carbon-14 is about 5,000 years. And so if you get too much older than 50,000 years, then we can't really measure that accurately how much carbon-14 is left. Yes, okay. So I'm seeing that most everyone has changed this to the loudspeaker. I'm glad, Seth, that you were able to guess right. I would be happier if there was at least some thought to get rid of some of the answers. So hopefully one thing you're gonna learn in class this year is how to go through and eliminate answers that are wrong to find the right one. Because that is a skill that will help you all the way through life. You'll be bombarded with different choices. If you can pick out which ones are bad choices, then you can make the good one. Yeah, always good to eliminate some. Yeah, once you get it down to 2, you got a 50-50 shot. Excellent. Let's move on here. This is a nice slide. I'm just going to make this giant for a sec. And is that gigantic for you, full screen? Okay. And so, do I still have my pointer? I do. So the way that this works, you know, the plant will absorb carbon during photosynthesis. It brings in CO2. Then the turkey eats the corn. And then they make the bone. The bone, when the turkey dies, the bone starts to degrade. So the carbon-14 is no longer being processed in and out of the turkey. So it starts to become, to do the radioactive decay. So every 5,000-ish years, half of the carbon-14 disappears. And so once they find it, then they can measure how much carbon-14 is left, and they can figure out how old it is. Do you guys have questions about that? Oh, you see. Hungry. All right, and when we work out these problems, it's 4th period, so it'll be on Thursday or Wednesday if you're watching the recording. We will go through that more and make sure that you have a good understanding. Because once you start talking about 1 half-life and 2 half-lives, then it makes more sense. So we'll do those problems on our long day this week. All right, so today we are going to explore the physical properties of some matter. So what are some physical properties of my Lamborghini? Yeah, it's yellow. Money, it's worth 0 money. Yeah, it has a door. Made of metal, yeah, metal. I think the wheels are kind of, well, the wheels are actually rubber. I could take the tires off if I wanted to. It does have some plastic. I think the windshield is plastic, the seats on the inside. The steering wheel does not turn. It does have some headlights. Okay, so what would be some chemical properties of my Lamborghini? Fiberglass. I don't think it has any fiberglass. It was a real one, maybe. So what are some chemical properties? It was real, it would run on gas? Yes. So if it was real, the burning of the gasoline to make it run would be a chemical property. What about the tires? Okay, but this is a good reason why I asked this. Melting, if you melt the metal, it's still the same metal. Therefore, that's going to be a physical change. And the melting point of the metal, maybe it's like 5,000 degrees, would be a physical property. If you burn rubber, then that's a chemical reaction to smell when it reacts with the oxygen, and it makes that the steam coming off of your tires, that would be a chemical reaction because it's burnt. It turned into a different material. And yes, if you were to cut the car in half, that would be a physical change. Yeah, part of burnout is a chemical change. The fact that some of the rubber ends up on the road, that's a physical change because you just moved it from one place to another. But the burn part, where you can smell the new chemical and you see the smoke, that's the chemical change. Yes, very sad there. Money burning would be a chemical change. So today, and even before the first interim, we're only going to focus on physical changes and physical properties. I just want like to compare and contrast a little bit so that it helps you differentiate them. It'll be easier when we get to the chemical ones. All right, so today's essential question is what happens during a physical change? And one little definition that you need to know, and that is the definition of matter. Matter has mass, and it takes up space. So, name something, yes, name something that is made up of matter in the chat there. And Seth started us off with air. More air. You matter. You are matter. Your phone is matter. Can you think of something that isn't matter? Well, light technically is made up of photons. When photons interact with other matter, they actually have mass. It's just like minuscule. The sun has an enormous mass. It's made all up of helium and hydrogen. Think about it. Think about it. There are some. Ooh, black holes have enormous masses as well. All right, what things are going through your brain right now? Antimatter. I don't want to go there. That's some deep physics. What's going through your brain? So, seems or senses? Right, atoms do have mass. So think about it. Think. The senses, like smell, but smell has to do with particles. Sight has to do with light. You're on the right track here. Something that does not have matter. Are you guys happy today? Okay, and so what is happiness or sadness? Yeah, your feelings don't have matter. They're not matter. They do matter, but they aren't made of matter. Thoughts was the other one I was going for there. Yes, you were thinking thoughts. They do matter, they're just not made of matter. Oh, yeah, but not in a literal sense, Seth. They do take up space. All right, let's come back up more to the surface and Oh, we're going to try the whiteboard out. I'm going to cross my fingers and hope this copies to the whiteboard. I'll put me away. And can you guys circle all of the images that are matter? It's working. Come on, guys. There are 23 of you in here. Pick up a tool from that right-hand bar and circle something that is matter, or square it, or hexagon it, triangular it. Awesome. I think the pencil's feeling slightly left out. It hasn't gotten its own circle yet. Hey, there we go. All right, cool. I missed that option for you all to write, so I'm so happy that it's working now. Yay, I loved write on the whiteboard. Okay, so today's class structure, we have, let me make this a little bigger. We have time for you to go through the lesson, and then we'll come back with some questions. Should be about 10 minutes at the very end to recap. And a couple of cute memes for today. Any questions thus far? And if not, you can give me a green check and I will send you to the breakout room. I am in my physical science class here, and I'm going to go to modules. This is to find the recording. So I go to modules, and then you can even see it right here on the screen. I put it right towards the top. Class recordings, and then I have the most current week at the top. And you can see the date there in the name. So for yesterday, this is the one right there, 8/26. If you needed something from last week, occasionally one of them has two parts because I hit stop recording instead of pause. But there's one for every single class that we have thus far. In question 2. I don't know, I didn't see that before. Okay, so question 1. Here, let's recap. A physical change does or does not affect the mass of object 1. So type your answer in chat. Let's just type them, but don't hit enter real quick. And I'll give everyone a minute to type their answers in, but don't hit enter. We'll all enter them together. So number 1, does or does not? All right. And in 3, 2, 1, we'll hit enter. 3, 2, 1, enter. All right, so a physical change. So if I cut the car in half, is all the mass still there? Yeah, I think some of you all read it wrong. So it actually does not affect the mass. I'm going to try annotation again and see if it's working. Oh my goodness, it worked twice. Okay. So a physical change does not affect the mass. It might affect the number of pieces there are, or, that kind of thing, but no effect on the mass. All right, number 2. Number 2, physical properties can be blanked and do or do not change the identity of the substance. I'm not sure I really like that first part. Again, I I didn't write the questions for today. So what about the second part? I'm thinking I'm going to go with observed, because that's kind of weird. I would pick observed there. And I didn't write this question, so so I'm going to go with observed there, because I wouldn't have picked those words myself. Okay, so physical properties, do they or do they not change the identity of the substance? Do or do they not change the identity of the substance? All right, so type them in the chat, but don't hit enter. Okay, well, let's go ahead. Go ahead and put them all in there. I wasn't practicing my waterfall technique very well there. So do or do not change the identity. So if I take metal, the car, and I melt it down, is it still the same metal or is it something different? It's the same thing. So the identity has not been changed yet. So physical properties, physical changes, probably would be better, do not change the identity of the substance. Boy, these were good questions to ask. I found some things you didn't know. All right, and we're running out of time, so we're not going to do number 3, but maybe you could put an example in the chat real quick. A physical change results in the change of physical properties. So what's an example of a physical change other than the 3 here? We got breaking a pencil, melting ice, and crushing a soda can. Oh no, I don't want you to be scared. Oh, just use your brain to think of a physical change. So pick something up off your desk, and how can you physically change it? Yeah, you can take a paper and ball it up. You could color the paper. I could paint the car, or I could sand off the paint off the car. That would change it too. You could crush the water bottle, shred it, sure. Not burn the paper, nope. Burning the paper would be chemical. Good. You could break the cup, definitely. All right, so it is now 12:30, 11:30. Yes, you could definitely make something wet. That would be a physical, it's really a physical change. I mean, it changed it, but physical change, it's the same substance, but it's a different shape or a different state. So you could freeze your water on your desk. That would be a physical change. But we are out of time for today. I don't want to run over our 11:30 end time. Thanks for coming in. And if you have a question, you're welcome to pick up the phone or send me an email, or you can stay here for a sec because I'm just going to lunch.